Okay, let's finish off this section with a little bit of terminology and hopefully put things into perspective for you. Just see if I can make a new one of these. There we go. Right, I'm going to get rid of this image. And I'm going to take these values out here. So, first of all, terminology and keywords. Okay. So, one keyword is analog. Now, what analog is basically the sound wave, and the whole point of the word analog is that the line on the waveform is continuous. That means there are no gaps whatsoever. Every bit joins to the next bit. If you take a look at the digital signal, there's rather large gaps from one column to the next column. It only represents the actual digital signal. And to go from an analog line like that with no gaps in it to a digital one is called analog to digital converters, and all computers have them. It's the way, so if you're using a microphone, that sound that you record into the microphone goes to some chips called analog digital converters and converts them into binary. And there is also the reverse. There is also digital to analog converters, and that would be what you hear out of your speakers. So if you're recording through a microphone, you're starting off analog, it goes to digital in the computer. When it's being played in the computer, it's digital, it goes to the speakers, that is converted from digital to analog, and that's sent back to your ears and you can hear the sound properly. So that's analog to digital converters. When we are looking at this line here, this sample rate, we call this sampling. So if I just give another word there, sampling. And although I've got a sample rate and I've given it a value, we can measure the distance between any two samples, and usually that's in sort of milliseconds. So each sample is of a value millisecond. So we're really measuring this distance between 2 points that we sample. And maybe a common value for that would be something like we sample every 5 milliseconds. That will give us thousands of samples in a second. So it really is that fast. So that 5 milliseconds is called the sampling interval. So the interval in which we sample. And it just means that gap there, just one of those gaps, not all of them, just one of them, and how long that takes in time. The problem with digital data as well is that if you take a look, this is our original waveform, it was continuous, and when we convert it to digital we get sort of columns, but they're not continuous, there's big jumps between the next column. What happens there is that we experience, when we convert from analog to digital, a loss of data, and we can't put that back. We can never guess what it was between the two samples. So if I look here, I can assume that going from this first column to the second column there was a jump, and that there'd be a midpoint halfway between. It's not always the case. It could be a lower sound that was going on there. I might accidentally miss this gap, this dip here when I was sampling. If I'm sampling in the middle there and sampling in the middle there, I might get the same value and miss the fact that it's dipped and think that it was rising. So I've lost data, and if I try to reconstruct the original waveform, I can only guess at it. It will not be accurate. The sampling frequency. So sampling frequency means how many times I sample per second. So it's this line here up to 1 second. So here I've got 44,000 times per second, or 44.1 kilohertz. That is known as the sampling frequency or sampling rate. We've used the word rate at the moment, but they might also use the term sampling frequency. They both mean the same thing, and it gives us a number like this. I've removed the seconds and I've removed the bits, because if I take this formula here and I take the seconds off that, so I'm just multiplying the sample rate by the resolution, and sometimes they call the resolution sample size. So I'll write that down here. Sample size is the same as resolution. I'm just trying to work out the different words that they could use on the exam paper, which could throw you. You might just learn it as sample rate and then be asked about the sample size instead of resolution, and it might confuse you. So these two things are equal, sample size and resolution, and it's normally in bits. But if I do that, then it's not the number of bits to store, really. This would now be called, well, it'd be measured in kilobits, thousands of bits per second, and that is known as the bit rate. So the bit rate is in kilobits per second, and it's the sample rate times the sample size. So notice what I did there. I just took the seconds off and the bits at the end of the day. So this would now be called the bit rate, and it's just these two values multiplied together. So the rate being 44,000 times per second, and the resolution 16-bit, 8-bit, 24-bit, and so on. And there is a limit, as I've said. If the rate is too high or the too much resolution, it really is a waste of time storing that information, because probably only dogs will be able to hear it. So the important part is that to increase the quality of sound, so if we want to increase the quality of the sound that we record, what we need to do is increase the sample frequency. So the sample rate needs to be up. So the more, or the larger this number, the better the quality. And as I said, there is a limitation. If we increase the resolution, it really gets louder. So if we increase this sample size, what really happens, so if we increase the resolution, what we're actually capable of doing is picking up quieter sounds. Because from physics, if you've done sound, you should know that this axis going up here is the amplitude, which is really volume. So this is low down here, and this is loud up here. So increasing the resolution and increasing the sample rate will increase the quality of the sound, but there is a limitation. And that is pretty much all we need to know about sound. Go over it, try to understand it, try some of the calculations. I will set you some questions. There was one further thing that was just bouncing around in my head. Yes, okay. At the moment, this is for mono sound. It's just one item. So if I kind of go back to this equation when I was working out number of bits to store, if I was doing mono, so if you've got a pair of headphones and it plays the same thing in both ears, then this would be the correct storage. However, if you've got stereo and it plays in 2 channels, so let's get channels on here, sound channels. If you play in each ear, then you've got to multiply this by the number of channels. So let's just pull that across, times channels. Obviously, as we're dealing with mono, that's 1 channel. It will not change the size here. We're just multiplying by 1. But if we're playing with stereo, we will double the amount of storage space we need. So if this stores 24 bits, but if I want to do it in stereo, and that wasn't for that calculation, what did we have? We had a sample rate of, I think it was 8, and a resolution of 3 for 1 second. We had 24 bits stored. But if I also increase this to have channels, then I need to change my equations accordingly. So an 8, let's just change this, 8 per second. So if I've got 8 per second, that's 8 hertz over 1 second using 8 bits. Or 1 byte would give me this value with 1 channel. If I wanted it to be stereo, so I've got 2 channels, that would become 48 bits. If I was using 4 channels, perhaps I was trying to record sound from 4 different instruments, then I would require 96 bits to do the same thing. So often the channel is missed out. They just assume mono, but be careful if they ask you if it's stereo. There'll be 2 channels, so you'll need to double the amount of bits in your formula. So that's basically all of sound. I think it's better that I've done this on video because you can go back over it. I've probably made plenty of sort of mistakes or said the wrong thing at times. It's what happens when you just make a video. Essentially the information is correct, certainly the calculations are correct, and the words are correct. I can't imagine how we'd have done this in class. It would be quite a tough one to go through. So it's a nice medium to actually do it. If you have any problems or don't understand them, please come back to me and I will try to explain it. There is a lot online. BBC Bite Size will probably cover sound. I know the exam boards might have different ways of representing sound. I do recommend that you look at it. I do recommend that you do some research on sound. It does appear as a question in most exam papers because it's so tough. And obviously it's worth some useful marks, particularly if you've got a high pat. So have a look, understand it. Again, if you've got problems, come back and see me about it.